Network. I better inform everyone that this meeting's being recorded, so that if anyone missed it or wants to go over the information later, we can send out the recording. We've brought this field day together 12 months belatedly. This was supposed to happen 12 months ago, a live field day sequence across the Central West. Of course, a little virus got in the way and all the lockdowns. So we put it on pause and we went again this year. The Climate Resilient Soils Network, just to give a bit of a brief background, it's based on a Smart Farms grant from the Australian Government, Department of Ag, Water and Environment, and a collaboration with Ian Potter Foundation, Australian National University, and a few land care groups around the district. So Margaret, Central West Loch Land Care, Little River Land Care, Mid Lachlan Land Care, and Central Tablelands Land Care, and Maddie over at Watershed Land Care over at Mudgee is also. So thank you to all those participants and all the help that you've given over the time. We set up a group of farmers called the Climate Resilience Soils Network to look at ways that we might be able to increase soil carbon in soils, and in particular soil health, with the context of it being practical, adoptable and profitable. So systems that increase our soil carbon stores but don't send us broke trying to do it. And the best place to start is to actually go to some of our more innovative growers, people that are trying things, and just scanning the districts for people that are trying new and exciting things and basing them on good principles and adopting already established methods of increasing soil carbon, and applying science to those paddocks, measuring what's actually happening and reporting what's going on in those paddocks, putting things under the microscope a bit more, so that we can aggregate that information, put some science and validation around it, so that we can spread that information further and wider to other people looking at some of these systems, but haven't actually jumped on board and tried them as yet. Simply because showing is better than telling is the old adage. And if someone's tried it and had a win and looks like they're having some success with it, other people are more likely to be more comfortable with adopting those sorts of techniques. And what we've found over the years, that there's lots of great growers out there doing some fantastic stuff that are really breaking new ground. And that's, I think, where the exciting part in all this is, finding ways that we can build our soil health. And particularly this project is focused on the cropping systems. We do other projects in grazing systems and more perennial systems, but this one was more focused on cropping, because it's really easy to lose carbon in annualized cropping systems, and it's really hard to store carbon in these systems. They've got a lot against us, and Susie Orgel, Dr. Orgel, will speak later about that today. So we have 3 sessions that'll go for the next 40 minutes or so. It'll be in the paddock with our first patron farmer, Luke Wood, who will take us. He's actually out in the paddock at the moment, so it is a field day. He's the only one in the field, so it is technically still a field day. And we've got a little bit of a video that we've taken over through the season that we'll play in a minute, to give some background on one of the systems that we're looking at that Luke's running there. Then we'll have a conversation with Luke around his broader systems and what's happening on his farm, and why he's doing what he's doing. Then we'll go over to Susie Orgel from the deep dive. She'll give us a bit more of a deeper rundown on what drives soil carbon and why we want to head towards building soil carbon. We're lucky enough to have Tegan Knock here today as well from Soil Carbon Co, with a soil carbon endophyte technology that they're working with out of Orange, and that Luke's got running on his property this year. Then we'll all get together for a discussion, as we do at field days, stand around with a cuppa and kick the clods, even though it's virtual. We'll kick some virtual clods, and we'll actually really encourage everyone to join the discussion group, and that's what makes a good field day. And we'll get some good questions going, and Luke and Tegan and Susie and myself will be on the panel to hopefully keep the conversations going. So without further ado, I think, Steph, we might hit the play button on the video, and then we can get to have a bit of a chat with Luke. Thank you.
We've been actively trying to improve our soil for probably 15 years now. First thing we did was to buy a disc seeder. Pretty much been no-till since that time. We reduced our stocking on our cropping country to try and maintain 100% ground cover even through the summer. Then I guess the next step was to try and get everything onto the 3 metre centres on 9 metre swaths, and that probably took us 10 years to do. That's all in an effort to build our soil biology, and a good measurement of that is your organic carbon. So this paddock was sown to arrowleaf clover last year. We had a bit of a graze out of that. We also harvested it for seed. We certainly sprayed a lot out the back of the header, and there's a good amount of seed here in the seed bank. And what we did was we did do a knockdown before sowing this winter type canola. But the arrowleaf clovers come up through that.
Luke's only it's mad enough to have a go at doing this. It's Luke's idea, not ours. But when we heard about it, thought this is fantastic. This is exactly the sort of thing that we're really interested in. That legume's fixing nitrogen all the way. It's got nitrogen fixing bacteria on its roots, the nodules. To really grow carbon in the soil, you still need moisture and nitrogen. They're the two big things that you need to make carbon. But if you can use a natural form of nitrogen, it's a far better way to make that carbon stay in the soil. And so this system's, we've got high hopes that this might be a great system to do that.
I think the trial that we're involved with Soil Carbon Co will be important, particularly if we can show that something as simple as coating your canola seed with a fungus can significantly increase your organic carbon while doing everything else exactly the same. It's pretty simple way of buying carbon in a packet, basically.
Thanks for that, Luke. Sorry, everyone, the video was a little bit laggy, but not much we can do about that with so many people on the line. We're lucky to get it to feed through, really. But you could see there, Luke was out in a couple of paddocks there, in his wheat paddock and also the canola paddock with the arrowleaf underneath it. We particularly wanted to have a chat around that canola paddock. You saw in the video where it was at. That was back in June, July, Luke. I'm trying to think. Maybe a bit later, actually.
It would have been July.
July. So nice. Yeah.
Paddock then. Yeah, since then, fair bits happened, I suppose. It didn't look all that impressive then, but it's 970 probably doesn't at the end of a graze, but yeah, it's come a long way and looks pretty good now. Little bit concerned about what the arrowleaf's going to do in that paddock, but yeah, worst case scenario, we might have a bit of grading to do to get that arrowleaf seed out. But yeah, obviously the 970's got a bit of leg about it, and should mostly be out of the seed, or the arrowleaf seed range. All going perfectly. We might get to harvest more arrowleaf once we've harvested the 970. So last year we had the arrowleaf in January, and our 970 here was early December. So that's a bit of a fantasy, but yeah, may work. We'll see.
It could work. Yeah, that's right. The interesting things as we've been discussing this paddock over the months is the strategies that you've been thinking about. Like no two seasons are the same. And you've always got to have an opt-out and a way to manage your way through with these sorts of systems. And it's interesting, I found your thinking process on the total setup of this paddock. And before we go into it too deep, it might be just worth 10 seconds just giving us a quick iPhone view of the crop at the moment. So you might have seen in the video, it was sort of only a foot high and looking all sorts of colours that canola will do in the winter. Keeping in mind it's 970, so it's a long season canola, winter type. And I haven't been out to the paddock for a little while to see it because of the lockdown. And Luke sent me through some photos a couple of days ago, and it's certainly it's sprung ahead. Really interesting to see just where it's got to at the moment. So you can see there. Here's the big show-off picture up to Luke's head. Show us where the arrow leaf is up to there, and there's a sub-story to the crop there now, Luke. It's down around knee height or better, is it?
It's not over the camera, that might help. You can see my hand there.
Yep.
That's about waist height. And that's the top of the arrow leaf at the moment. And it's just starting to get buds on it. And the top of the canola at the moment, it's about 6'6", I suppose.
Mm. Yep. So you're going to, theoretically, you'll get the two crops coming in at different times. The pod set will be at slightly different times, you're hoping?
Yeah, well, I'm wanting the canola more so than the arrow leaf, so we'll manage everything around the canola. We're hoping that the arrow leaf will mostly be under where the pods are on the 970. We're going to direct head it. We've done that in the past with it, so we're comfortable direct heading the 970. Last year it was our highest yielding canola ever, and we're more than comfortable direct heading that. So I don't think that'll be an issue. It's a matter of where the arrow leaf is up to at the time when we need to harvest the canola. May need to desiccate the arrow leaf to make our sample acceptable with the canola. I don't know, it's nice to have a good year to be able to play around with something like this. If it was last year, we probably would have sprayed the arrow leaf out and not worried about it. We're just going to see what it's going to do.
Yeah. And that was my where I was heading with your contingency plans for this paddock. Were quite impressive. You're doing something a bit unusual, growing an intercrop with a legume under the canola. The setup of it is you had arrow leaf last year, and you used the arrow leaf just to sow in with a direct drill machine on controlled traffic. So you got full stubble retention, still full controlled traffic, no-till system with an arrow leaf as your rotation crop, filling the ground full of a bit of nitrogen that obviously this crop's enjoying now. You've had fairly low synthetic nitrogen input as well, you were saying. What's your fertiliser program been here?
This paddock was first year arrow leaf last year, so that was harvested. It grazed that as well. Yep. There was, well, input wise, I've just got it written down on the phone here, so I'll just read that out. We did one summer spray, a knockdown and pre-emergent was propizamide, 30 kilos of MAP. It was 1.5 kilos of seed. We did 2 foliar sprays, which had nitrogen, sulfur and traces in it. We did a grass spray, and just rough figures on that. It cost us, out of the pocket dollars, was $250 a hectare, plus fuel, plus machinery.
So it hasn't cost you a lot when canola's at 970 a tonne, if we can get it in the bin. That's the overview for us from SoilCQuest point of view. We're interested in this way of doing it because we're using a lot of legume nitrogen, and hopefully Susie might touch on that in her talk, Carbon 101 talk. But driving the carbon production underground to build more soil carbon is a lot easier with legume nitrogen than synthetic nitrogen. There is quite a lot of research coming out more recently now that it does make it a bit harder to store carbon in the soil using synthetic nitrogen. But how do you get yield? You've got to have nitrogen to drive yield, and carbon production in the soil is nitrogen related as well. So you still need nitrogen, but it can be a good friend, bad enemy sort of scenario. The good friend part of it is the legume component. So how do you get enough legume rotation and enough legume influence in your cropping systems? It's always the $1 million question, depending on the vagaries of the pulse market and various things. In this way, we're growing a pretty hardy sort of a legume with arrowleaf, a hard-seeded legume that fixes a lot of nitrogen, enough to support who knows what this crop will do, and it is a cracking season in the context. But we're driving the whole system with ample nitrogen for the crop and for the soil to actually build soil carbon with a big biomass crop. So the carbon input going underground is huge, as well as being complemented by the amount of nitrogen that's being fixed. So it's the perfect scenario to help build carbon in the soil. The other thing, if we ever do get to carbon trading, where we can monetize the carbon we're building in the soil, we've got to count what our offsets are worth at some stage as well. And if we're using a lot of synthetic nitrogen in the soil, and in my agronomy days, I saw each year an increasing level of nitrogen going out the door, trying to keep up. And the numbers are that our soils in continuous cropping are losing the ability to make carbon themselves by about 3% a year, I think is the figure. So we do need to work out how we drive more nitrogen with legumes, and it's hand in glove with building carbon in the soil. We've probably only got a couple more minutes here, Luke, but I did want to talk also about your cover cropping more generally. You're looking at a whole range of things, not just this paddock with the understory of arrowleaf, but you've actually had a bit of a play over the years with cover cropping and summer rotations and so on in your systems as well, trying to drive that soil health. I wonder whether you could touch on some of your experiences there. The good, the bad, and the ugly.
Yeah. Coin a phrase from Mick Whitnall, we've taken a bit of bark off, but we've seen some interesting things as well. We've got a 600 mil rainfall, and it's spread evenly throughout the year, on average that is, of course. And our soils can probably only hold a quarter of that at a time. So if we're running a summer fallow every year on our cropping country, we're undoubtedly wasting moisture. So in good years, like we've had in the last 18 months here, we can sustainably grow 2 crops a year. It's undoubtedly better for your soil to be doing that rather than having a 4 or 5 month fallow. Yes, that will conserve moisture, and you will get some nitrogen out of that fallow doing that. But at the end of the day, moisture is probably more of a limitation or a driver for us. We're trying to use that as efficiently as we can. So we're finding that if we can double crop in some sense, we're better off doing that than letting the country lay idle for 4 or 5 months over the summer. So we have double cropped grain sorghum here after barley crops. The neighbours given it a crack after canola, which we were a bit nervous about with insect pressure, but didn't seem to be a drama. Getting that crop off before winter can be a challenge, but yeah, it's a challenge worth taking. I think particularly in years like this where limited water isn't limiting, and I suppose research is showing that summer fallow is where we're limiting ourselves with our our ability to build carbon as well. So we're trying to get our organic carbon as high as we can, just to build some resilience into our system. I don't think we're seeing the response to phosphate fertilizers that we probably have in the past year. We haven't eliminated them, but we're way back on where we might have been 15 years ago, and I just don't think we're seeing the same response as we used to that.
Based on your soil health improving.
Yeah. Yep.
Phosphorus mineralisation and so on. And the other thing in that rainfall zone is similar to where the cover cropping trial was at Canowindra down the road from you. That it's a good point. The summer fallows are one of the big leakage points for carbon in our system. So we put it in the winter, and then it leaks out in the summer as we spray our fallows. Finding a way around that, particularly in some of the inside country east of the Newell Highway, where it's probably a bit more doable, seems important. And the trial that was run down the GRDC trial that was run down the road from you showed your infiltration rates have dramatically changed with your cover cropping process. Even though you might steal a bit of moisture from the fallow moisture in the early part of the season, if you terminate it early enough, you've got infiltration, and the opening rains, all is forgiven, and fill back up the profile in an ideal situation in that particular trial anyway. So we might have to leave it there. I'm just looking at the time, and we're flying through the session. It is a bit different to a field day, actually being out there where you've got all day. So I might thank you very much, Luke. If you'd like to hang around, that'd be great, because we'll have a panel at the end of the session. I'm sure that there's going to be some questions pop up, what Luke's doing there, and to dig and delve a bit more. Keep in mind with any of the speakers, if we don't get the questions covered in the panel session, then we'll definitely answer emails and so on. We'll keep the conversation going after the seminar. It is being recorded, so you can go and refresh yourself of what was talked about and think up some more questions. So I'd like to introduce Dr. Susie Orgill. So Suze is the leader of the Soils R&D Group, the Soil Carbon Research Officer for the Department of Primary Industries. I think I've got that right, Suze. Have you got an updated title?
No,
there?
That's good enough for today. Yep, sounds good.
Good enough for today. All you need to know about Suze is the t-shirt that she's wearing, that Soils Will Save Us. She really is a soil nerd. She's one of the best minds in the country on soil and soil carbon, and just really we've found her just so passionate about the subject, which makes it really inspiring to listen to. So over to you, Susie. I've pumped up your tyres now. So
I know, I feel like I'm starting a bit embarrassed. I'm blushing. So thanks, Guy, and thank you very much for the invitation to be part of the virtual field day today. Absolutely wish I was not stuck in my office and was out kicking clods with everyone and talking about soil carbon, but this is definitely the next best thing. As Guy said, I'm a soil carbon researcher based at the Wagga Wagga Ag Institute with New South Wales Department of Primary Industries. I'm really passionate about practical options for producers to increase soil carbon. And I want to start my presentation by talking about the flows of carbon around the landscape. So this slide for me really articulates how we can influence practices and processes which build soil organic carbon. So if we think about, to begin with, how carbon gets into the soil, through the process of photosynthesis, we know that plants use carbon dioxide from the atmosphere, water, and energy from the soil to grow and photosynthesize. So they use this sunlight to create energy, and it goes from carbon being a gas in the atmosphere to being a liquid in the plant and forming the structural elements of the plant. What this actually means in the soil is we have this above ground supply of carbon through leaves and litter and manure if we've got grazing livestock. And we've got this below ground accumulation of carbon as well in plant roots and root exudates. Now, the root exudates are the carbon-rich signals that plants leak out of their roots to make sure that microorganisms will come and live within the rhizosphere, that really thin film of soil that surrounds plant roots. Now, this process is what we need to understand, because if we're growing bigger, healthier plants with deep, extensive root systems, we've got a strategy which can start to build soil organic matter. Now, soil organic matter is composed of 58% carbon and a whole heap of other nutrients. So nitrogen, phosphorus, sulfur. And that's why it's a really important process for nutrient cycling and plant available nutrients as well. Now, once the organic matter is in the soil, it can go through several different pathways. So that organic matter can be protected within soil aggregates or soil crumbs. And when we say protected, it's protected from further decomposition. So we know that there's some practices, such as minimum tillage, which will preserve soil structure. Other practices, such as perennial pastures and legumes in our cropping systems, which will enhance soil structure. So we can enhance the protection mechanisms of soil organic matter in our farming systems. Now, organic matter can also be chemically protected. So it can be decomposed into a more stable form of carbon in the form of humus, which is that dark substance when you pick up a nice, healthy soil and look at that dark substance within the soil. And that's a very stable form of carbon. And that's composed primarily of microbial organisms, so microbial detritus and their products. Now, carbon can also be stabilized in the soil when it becomes associated with clay minerals. So through organomineral associations, organic carbon compounds can be stabilized. And that's why typically we see higher rates of soil organic carbon sequestration and higher soil carbon stocks in our clay soils compared with our sandy soils. As I said, though, this is a flow of carbon around the landscape. So understanding the type of carbon can tell us about its vulnerability to change. It can also give us an indication about what's going to increase most rapidly. So humus is the major part of the soil organic carbon pool. It's typically between 60 and 80% of our total organic carbon. It's very stable, it's nutrient and energy rich. Our particulate organic carbon is the most sensitive to management, and it increases quite rapidly, but at the same time, it can decrease quite rapidly under drought conditions. And then we've got our charcoal. Now, our charcoal component of the soil is a very stable, relatively inert fraction, but it's a really important habitat for our soil microorganisms. Now, with this flow of carbon, we've also got carbon leaving the soil. Now, carbon can leave through plant and soil respiration. So as soil organisms decompose organic matter, they respire just like we do. But this is a really important function of organic matter because it's energy in the soil, it's food and it's habitat, and it's continuously cycling and it's dynamic. Now, the one other type of loss that we can manage, though, is via soil erosion. So as soil is physically removed from a paddock, associated with that soil particle will be organic carbon. And certainly practices which maintain ground cover and enhance the structural stability of the soil surface, we can reduce or minimize the loss of carbon via soil erosion. So looking at this slide, we know that management can influence biomass production, both above ground and below ground. So more carbon going into the soil. Our management practices can enhance the protection and the retention of organic matter within the soil. And our practices can also influence the efficiency of organic matter use by our soil microbes as well. But soils vary in their capacity to sequester and protect carbon. When we look at a soil organic carbon result on your soil test, it's the result of a balance between carbon supply, so biomass grown in situ, or carbon brought to the site in the form of compost, for example, and carbon loss through that decomposition process and also through erosion. Now, this balance is going to be modified by a couple of things. It can be modified by the type of organic matter, so whether or not it's high in nitrogen, so such as legume organic matter, which Guy was speaking about earlier, or whether or not it's high in carbon, so wheat and stubble residues, for example. And that's all related to how vulnerable that organic matter is to decomposition and use from our soil microbes. Now, the soil's capacity to store carbon is influenced by not only the amount of clay, but the type of clay as well as the soil depth and the soil structure. Now, all of these factors drive productivity. So it's what we think about every day when we're thinking about land suitability for different crops or different grazing. And some can be changed. For example, the plant type and soil structure can be influenced, but some can't be easily changed, such as clay and soil depth. So why are we interested in soil organic carbon? Well, we know that our climate's getting hotter and drier, and we're experiencing more extreme and variable events. Now, this is going to impact on our ability to produce food and fiber. And we know absolutely that soil is an important land-based solution to climate change. When I think about this, soil fitness is central to resilient farming systems. So resilient farming systems, we know, are able to be adaptive. They can absorb stress, they can maintain function, and they can bounce back from different events such as droughts or periods of extended dry. Now, soil organic carbon influences 5 essential components of soil. The first thing, cation exchange capacity. So the soil's ability to hold on to and exchange nutrients. This is often an inherent indicator of soil fertility. It's the sum of our calcium, magnesium, potassium, sodium, and aluminium. And we know that 1% increase in soil organic carbon in sandy soils can increase the cation exchange capacity by up to 90%. So basically we have our clays, which are negatively charged. So they help hold on to nutrients in the soil, but our organic carbon molecules are also negatively charged. So by increasing organic carbon in the soil, we can increase the soil's ability to capture and hold on to those nutrients. We know that soil organic matter is an essential component of energy for our soil microorganisms, and our microbes enhance soil structure through fungal hyphae, for example, or through polysaccharides that bacteria excrete, sticking soil particles together, making sure that our soil is well aggregated and stable when it gets wet. And if we've got enhanced soil structure, we have a greater ability for soils to hold on to water. So we can increase our water holding capacity by 1/3 with increasing soil organic carbon. And we've also got a structural soil which can allow for root exploration and oxygen exchange. So that's all really important functions of soil organic matter. The sandier the soil, the more important these functions are. But all soils require organic matter for soil functions. So for the provision of plant nutrients, so a 1% increase in soil organic carbon gives us over a ton of nitrogen, over 200 kilos of phosphorus, over 160 kilos of sulfur. That's all money in the bank or money in the soil, for example. And it's essential for the energy of these biological processes. It's essential that we start thinking about our soils as an ecosystem and carbon as the energy currency going into that ecosystem. So we've got our soil organic carbon concentration. That's the total organic carbon in the soil, the grams per 100 grams of soil. We've got our soil organic carbon stocks. That's generally reported to 30 centimetres, and that's the tonnes of carbon per hectare. So we calculate that using our carbon concentration, knowing the depth of soil and knowing the bulk density of the soil, which is the mass of soil for a given volume. And then the other thing we talk about with regards to carbon trading is our carbon dioxide equivalence. So 1 tonne of carbon is equivalent to 3.66 tonnes of carbon dioxide in the atmosphere. Now, the reason I wanted to run you through that is my next 2 slides give you some figures on carbon sequestration rates across New South Wales for known and tried and tested management strategies. There's no spooky science here. This is all good practice and good agronomy. And we know that it leads to systems that can build soil organic carbon. So you'll have access to these slides afterwards and you can look through what these strategies are. But essentially, they're strategies which overcome a soil constraint, for example, liming or applying gypsum to a sodic soil. It's through managing plant nutrition and it's through grazing management. So management which keeps plants in actively growing stages. Now, legumes and perennial pastures are absolutely key in pasture systems, but they're also essential in our cropping systems as well. So looking at pastures, we can see that through these practices, we've got sequestration rates which range from 0.1 tonne of carbon per hectare per year sequestered across 30 centimetres up to 2.5 tonnes of carbon per hectare per year. If we briefly look at crops now, we can see that we've got rates which range from 0.2 to 1.5 tonnes of carbon per hectare per year through practices such as legumes in rotation, through minimum tillage, through nutrient application, and through organic amendments and direct drilling. So we know that the science is there, right? We know that you can build soil organic carbon in our systems. We know that it's not linear. It increases rapidly in the first 5 to 10 years, then plateaus off. And we also know that there's real, I guess, benefits in terms of productivity. So our work has shown that we've got benefits of up to $95 per hectare per year just in productivity of increasing your soil organic carbon concentration. So these are the strategies that you could do tomorrow on your farm to build soil organic carbon. It's going to be dependent on your region, it's going to be dependent on your soil type, and it's going to be dependent on your motivation as well. Essentially, what I think is you need to think about your soil as an ecosystem. The strategies in the bottom here are ones that are coming online now around mixed species plantings, biostimulants, and microbes that store stable carbon, which we're about to hear about. And I think this is the super exciting space for soil carbon science and more opportunities to build carbon in your soil.
Brilliant, Suze. Thanks very much for that. I think I've learned something. That carbon figure you put up there, Suze, is that soil organic carbon or just carbon? Can you multiply that carbon number by 3.66 to get your CO2?
Absolutely. Yep. So that was just soil organic carbon. So if we were going to make it into carbon dioxide equivalents, you're right, we multiply it by 3.66.
Great. All right. As Sue said, that this will all be available for everyone to go through that. There's some really good, as you say, just basic good practice that we can apply to our cropping systems without getting too excited to start with. And they're the foundations that I think we need to really consider, everything on that list that we can build on, and then we can layer over it things that Luke's doing and what Tegan is about to talk about as well. So for those who may or may not know, Tegan Nock helped SoilCQuest get on its feet some years ago. We're struggling not-for-profit, beating the drum for soil carbon and trying to get funding and all the rest of it. Tegan and a partner, Frank Ollie, who's I noticed on the call as well, came to the rescue and put in some massive efforts to actually get the organisation up on its feet. We basically, from that, we were looking at soil carbon sequestration using fungi, and that sponsored a startup organisation called Soil Carbon Company, which Tegan is the Chief Product Officer of now internationally. So Tea's got a big story to tell, but she's got 10 minutes to tell it in. But it's a really exciting story, and I hope that you certainly won't get all the story, but certainly keep your questions for the discussion time, and then after the session, shoot through some emails to get more information. So over to you, Teague.
Yeah, brilliant. Thank you so much, Webby. And exactly right. I am going to give a bit of a high-level overview of what's happening with Soil Carbon Co today, but please do, follow up with any questions. I won't be able to touch on everything because, as Webby said there, it's a rapidly evolving space, and a lot of the work that we're doing is fairly novel. So there's a lot to dig into with some of that carbon capturing inoculum work. But thanks again, Webby, for the invitation. You've got a brilliant lineup of speakers over the 3 days. And I'm pretty excited. There'll be a couple of our research partners that we work with as Soil Carbon Co on the call in the next session. So I'll leave it to them to dig into some of the information and the processes that we use to understand what type of carbon that we're building out with our microbial inoculums that Susie was referring to, the different types of carbon there. And I'll just run through what it looks like in terms of the inoculum, and that's the inoculum that Luke's been working with this year, overlaid with his carbon building practices. And in the spirit of the virtual field day, I will try and keep this as visual and as much of a virtual tour as I possibly can on Zoom. So just 1 second and I will actually pull up, if I can, a slide deck. This might take me a second. Actually, I've just lost my place. All right, here we go. Got him? All right. So as Webby said there, Soil Carbon Co, commercial entity. We're currently 35 people strong. And we've got specialists in the area of microbiology, genetics, soil science, agronomy across the team, and really focusing on some of the systems biology work that we do, and looking at how we can employ new technology to be able to capture some of that carbon that's being pulled in by plants that we're generating from that biomass that's being built out, and store them in some of the more stable proportions of the carbon of the soil, that we work with. So in terms of the technology that we've been developing out and is currently in its large scale trialing stages, we work with a group of endophytes. They're called dark septate endophytes. Now, DSEs differ from arbuscular mycorrhizal fungi in both the way that they form a relationship with plants, but more interestingly, their ability to actually increase the time that carbon is staying in the soil for. Susie spoke about the carbon flows, and these DSEs, they capture carbon from that flow that comes through from plants, and they are able to actually increase the protection mechanisms that Susie spoke about, and that slows that carbon leakage down from the system to a proportion that can offer, measurable and meaningful gains. The way that they do this is due to a number of unique characteristics to this group, but it's particularly their biochemical makeup, which makes the carbon-rich compounds that they're pulling out of that they're creating in their biomass, and enables those carbon-rich compounds to be more resistant to forms of degradation. Now, through our work, our research team has had the task of screening around 5,000 different types of fungi. They've shortlisted them down to 100 for those fungi that we're then really digging into and really working on and using in our R&D program. So you'll notice that this plate, it has quite a teddy bear look to it. It looks pretty soft and fuzzy. And DSEs are filamentous fungi, and they're made up of tiny hyphal branches or hyphae, as they're called. So if my slide deck will, this is those hyphae of those fungi up close and personal. So this is an image of one of our guys that was taken at the Australian National University under a scanning electron microscope. So you can see those hyphae and what they look like up really close, but these become the key contributing factor to that additional increase of carbon in the soil as we're measuring that in our program. But they also, you'll see that they have almost tunnels within their structure that enable that nutrient pathway between plant and fungi as well, which plays a pretty important role agronomically. So this is a 10,000 times magnification of these fungi. As we've gone through the process, we've done a lot of that kind of early screening with our fungi. We've genetically profiled them, studied them deeply, and we're really properly understanding then their capability and how these fungal hyphae interact with both plants and with soil. So this is another scanning electron microscope image, which the scale of this, for reference, there's the 20 micron scale that sits down at the bottom of that slide, but 20 micron is roughly the diameter of a fibre of wool. So this is very, very small in terms of what we're seeing on this screen here. But this is a soil from the central west of New South Wales. On the left-hand side of the screen there is that soil that's as is. It's not been inoculated with that carbon fungi. On the right-hand side of the screen there, if you look really closely, and sorry if anybody's got a small screen at the moment, but looking quite closely, you're able to see some of the fungal hyphae that's actually wrapping their way around some of those microscopic soil particles. Now, that hyphal growth and the way that they actually wrap that biomass around those soil particles contributes to increases in soil carbon, but a lot of that protection of that soil carbon as well. So in the form of aggregation, particularly being able to stop the degradation happening and that re-release of some of that carbon within the system. So fungal hyphae has been shown to be longer lived in soils than, say, your typical root mass, but DSEs are more resilient again when it comes to fungal hyphae, and that again is due to their biochemical makeup. So keeping in spirit with the virtual field day, I thought I would take us on a really quick tour of what it takes to get some of these fungi from Petri dishes and genetic codes through to building carbon out in the paddock at scale. I am just conscious of time, so I might speed through this and try and keep it as quick as possible. But in terms of what our team has done over the last couple of years, I'll head back up. As I said, it's around 5,000 different fungi that those guys have started from as a base and screened down to around 100. From there, they've walked those fungi out and start performance testing in greenhouses. So one thing to note here, and that was what Susie touched upon particularly, is the difference in the types of soils that we work with, and particularly things like their parent material, their soil texture and nutrient composition, but also things like what that native microbial community looks like in different soils. And that can have a real influence then on performance in terms of this carbon inoculum. So we test across a wide suite of soils. When we have strains and an inoculum that we feel have real potential then to be able to do some great things in the paddock, we bring them into research collaborations like our research collaboration with the Australian National University and University of Western Sydney to dig deeper and just really understand what it is that's driving that additional increase that we're seeing in terms of carbon, and also the plant benefit that we have coming across showing up in our data. From there, we head out to small plot sites and start to test them in a real world environment. So I noticed that Dr. Brooke Bruning joined the call earlier on, and at the moment she's working with us, and she has 34 different small plot sites that she's running across the country to really understand what performance looks like in different environments, and what performance looks like over different seasons as well, which is also quite important when it comes to that performance. So once the inoculum has gone through that process, we're able to then productize it, make it really resistant to agricultural supply chains and logistics. These here are some images of a spore-based product. So that's these fungi in a stable and deployable form, and that can then be used as seed treatments in an agricultural setting. So from there, we're actually then able to scale up and really start to deploy this en masse through that seed treatment process. And we're able to track and see what happens when you bring these inoculums into an environment where they are actually, working with those plants that are building out biomass. They're exuding carbon compounds into that soil, and those fungi are then converting that into some of the more protected forms of carbon. So we'll be really interested to see what happens at particularly Luke's place this year with such a big biomass here, and how much carbon we've been able to capture off of that in protected forms. So we've been through this process of screening right down, getting to small plots, and then testing out at large scale with our canola product at the moment, which is the first of where we're currently in 14 different crops, but it's the first one to hit that scale stage. It's been really interesting. This data has come from our 2020 trial year, and it's one to note that 2020 was such a big biomass year that we did have quite a big response across our trials. So on average, we were looking at around a 2.1 tonne increase in that season of application. And when we talk about then converting that to tradable carbon, that was converting up to a 5.7 tonnes of tradable carbon through that season. What became really interesting for us is also matching that up with that yield increase. So looking at short-term return on investment, but also then the ability to have that long-term increase in soil carbon, which, you know, ultimately is building out that resilience of that farming system, but also natural capital on that farm. So I will skip over this just in respect to time, but I just wanted to make a quick shout out to the team that's made this possible. We're a pretty rapidly growing team, and like I said, there's some experts that have come together and really put their brains to being able to understand more of the systems biology and deliver something to market that actually has kind of the practical applied side of things, but also is matching that up with a lot of the foundational research that we're doing, be it across our research collaborations or in-house. So hopefully next time that we're out of lockdown and all together, this photo will actually have a few more smiling faces in it. But until then, this is a team that's been working on that process. And just quickly, if anybody wants to reach out or is interested in any trials or the planting season next year, you can find me at tegan@soilcarbon.co. But thank you very much.
Take myself off mute. Great stuff, Teague. Thanks very much. There's some photos in there that I hadn't seen that have, very inspirational. That what was the one down at ONU? 10,000 times, was it? Magnification. Yeah, it's really interesting, isn't it? These things that are pretty much invisible to the eye, when you start putting them under the microscope and some intensive magnification, it all starts to consolidate in your mind how all this microbial stuff starts to work. And just doing some quick back of the envelope calculations there, both you and Susie touched on the impact of the potential of soil carbon to impact on our trajectory with climate change. And just some back of the envelope numbers there at that 5.7 CO2 equivalents you're quoting out of that trial. There's about 500 million hectares of intensively farmed cropping country in the world, and about 1.5 billion if you count the rangelands as well. But even at that 500 million, that gives you in one season 2.85 gigatons of carbon drawdown potentially. So you can kind of see why we're interested in this, because it's no small technology if we can get it right, and have it so it's as easy as a farmer just applies it to the seed, sows the crop as normal. All the other things don't change. The grower gets to choose their crops and their systems, but you can store that sort of carbon in the soil each season and keep building it, and it's recalcitrant carbon. Then you really do have a way to impact pulling large amounts of carbon out of the atmosphere and doing something really useful with it, putting it in the soil where it can actually give us agronomic benefits as well. So a real win-win there, and really well presented, Teague. That was fantastic. We might open up to the floor now to have a panel discussion. So if Luke and Susan and Teague want to be at the ready to answer some questions, I might just ask people to click the reactions button down the bottom of your Zoom call there, and that'll give you a hands up signal, and I can click on the hands up, and we can go directly to the person to ask the question live and in person. So if you feel so inclined, please don't be shy. Click on that button. Any problems with that, just or put it in the chat is the other way you could do it. So have we got any questions from the floor? Have we inspired you enough to inspire some questions? So while we're waiting for some raised hands, I should see the raised hands here, Steph, shouldn't I? Or you
I
see
can
them?
see a couple. Why don't we maybe start
See, I'm
with?
not seeing them here, this end. So
Okay, I'll alert you, Webby. So why don't we start with Michael Gooden? Michael, if you could just take yourself off mute. Yeah.
Yeah, great presentation so far. It's been excellent. I'd probably just call on Luke a little bit to explain your arrow leaf canola rotation, how that fits into your broader cropping rotation. And probably a little bit of a side to it is the non-mycorrhizal association with canola and how that is fitting in with your arrowleaf. Why did you choose arrowleaf? And yeah, just flesh that out a little bit.
Yep, righto. We chose arrowleaf purely because it grows really well here. Also, we can harvest it, so it's not going to cost us a lot to replicate this through the farm if it seems to work. We haven't had this scenario in the rotation before, so I can't say with confidence it's going to continue. But it looks as though it's going to be a pretty handy crop. We're fixing nitrogen at the same time. Obviously, for next year, we fixed nitrogen last year with the greys for this year. We don't seem to have a lot of success with too many other sort of grain legumes here. We've grown chickpeas, both types of lupins, grown a little bit of vetch. They're okay, but they're not anywhere near the cash flow that we get out of canola, canola, wheat, barley. So we're trying to eat our cake and have it too, I guess. We want to have the arrowleaf ticking away in the background some seasons. So being a hard seed, it'll come back each year, particularly having had such a big seed set last year. We also harvested 10 or 12 tons off this paddock, so we've got a bit to go around the farm now. As far as where it fits in, next year we'll be sowing this paddock to Kitty Hawk wheat, so it'll go in hopefully in the first week of March. We'll let the arrowleaf go again. I think it's something that we'll make a decision on a year-to-year basis. So if it's a fantastic year like this, we'll probably let it go a lot of years. Could be more of an issue in wheat, I guess, than 970 canola coming up through it. But worst case scenario, we'll be spraying it out and just go with the wheat to harvest. So Kitty Hawk wheat next year, then probably barley, then probably all going well, we would allow the arrowleaf to go through the autumn and winter. The year following that, spray it out and go to grain sorghum or forage sorghum. So that's where I envisage this paddock going from this point in time, but we try not to have a set rotation is probably where we sit with. We try and make our decisions on what goes into a paddock, on what the soil needs, rather than sticking to a set rotation.
I guess also, Luke, just fleshing that out, the arrowleaf clover, for those who may not know, is a very hard-seeded variety too. So it's a 7 or an 8, I think, from memory. So you've got
we probably, I would say we spat out half of what we harvested off. It's a 28 hectare paddock, so there's probably another 10 tonne of seed in the paddock.
It's a very small seed. It's hard to capture. But the long and the short is that you've kind of got it for a long time. You could spray it out in a season where you don't want it, and you haven't killed the seed bank because there's still a whole heap of seed there. And being hard seeded, it's not all going to germinate on one rainfall or 2 or 3 rainfall events even. It's pretty much almost in perpetuity that you've got that in there, that you can manage it as you need that nitrogen flow come into your system. So,
Yeah, and we'll have to be mindful of chemicals we use and where we use them in the rotation. We're basically, I don't think we've used an SU for, it would be over 10 years now. Lontrol we use very sparingly. If we're going to continue with a setup like this, I think we'll probably have to shelve it as well. It adds another complexity to the system, but hopefully it has a fit.
We might move on to the next question if everyone's ready. I see Helena, you've got your hand up.
Hey, hello.
Hello.
How are you going?
Hello. Okay, good. I'm glad. I've got a lag. I'm a bit out west. I have a question just regarding the DSE fungi. What is their naturally occurring conditions? So if they are found, obviously, in forested or what kind of environments are they home to?
Yeah, and it's a great question. The really interesting thing about DSEs particularly is how old they are on an evolutionary scale. And because of that, it tends to make them quite ubiquitous to a lot of different locations. So we know, for example, that we're finding DSEs here in Australia, that are in Canada, that are in the US, that are in
Amazing.
in terms of the particular environments, depending on, because they don't tend to be or they're not restricted to particular species. Depending on the species, you might find some that are more prevalent in riparian zones or some that are more prevalent in forest type environments. In agricultural settings, it's interesting that you don't tend to find them as much. And we think that that's because they tend to have
need establishing
longer term relationships with a lot of the plants they have originally established with. So being more of an annual based system, to be able to bring them in each year is something that you can then start to increase populations, but they do tend to be lower in agricultural systems, we've found.
Are they sensitive? Are they like a sensitive fungi to pH and temperature, or are they tough?
So it depends on which, but you can have some real extremophiles within DSE groups. And the good thing about that is then it tends to make them quite resistant to things like drought and extreme events. So, in an agricultural setting, they tend to be fairly robust and fairly strong within that type of environment.
Amazing. Thank you for that. I just wanted to quickly say as well, I met you and Steph at Mick Wettenhall's place when Down to Earth was there.
Hi, it's you.
But anyway, yeah, it's me. I've still got the polenta recipe, but anyway. Thank you, guys.
I will just be mindful of everyone's time. There's 2 more questions. Are our panelists okay to just hang on for 5 more minutes? Okay, so
We'll play them overtime if you like, Steph.
Yeah.
Has got to leave. Don't feel free to leave. As we said, we're recording this, but we've probably got a few burning questions here. Another couple of minutes might be worthwhile pushing on.
Yep, no worries. So there was one about sensitivity to temperature, which I think you just addressed, Teague. So actually this one is for Tegan from Sue. Are you seeing that the MEF inoculum sequesters more carbon in healthier soil, i.e. higher SOM, and or in heavier soil?
Yeah. And it's exactly the question that when we first set out, we knew we needed to answer very early on. And what we found is there tends to be a place where performance just bottoms out. So we've tested out in a soil that was a 0.4 starting baseline. And in a soil like that, we didn't see, obviously, any increase in carbon. The interesting thing that we did find, though, was the fungi was actually helping that plant scavenge from that soil. So there was a plant response in a soil like that. But soil carbon, I mean, you're starting from such a low base that the plants are even struggling themselves. What we have seen, we were testing out in soybean in our first year over the summer. And particularly in soybean, tend to have quite, you've got chocolate soils that you're working with. We had a soil that was around a 3.5 starting point for carbon, and had some very significant builds, ones which, if we can do that in those kind of soils, become really meaningful, especially if you're stepping into things like carbon trading. There's a real economic incentive to work in soils like that, even though they tend to be more intensive. The potential for us, we think, is much higher.
And I think just further to that too, it'd be pretty intuitive to most people that if we've got a healthy system, something like Luke's trying to achieve down the farm, it makes it much easier for the fungi to actually sequester the carbon based on very simple principles of the amount of carbon, the biomass of the plant dictates the amount that goes underground, and a healthy soil will grow a bigger biomass plant, just from that simple perspective. But obviously there's a lot of other mechanisms at play there that aggregate together to give us a better sequestration outcome if we adopt the whole system. And I guess that's what's kind of exciting for us. From SoilCQuest, we're a not-for-profit research institute, and we look at systems pieces. So we step on farm with people like Luke and so on, and try to nut out complete systems right through the technology, which is Soil Carbon Company attempting to bring about something that hasn't been done before, a carbon endified onto the market to make it even easier for growers to store carbon. So we've got this two-pronged approach with the two different organisations trying to deliver the same outcome of increased carbon. How are we going for questions there, Steph? We got more, have we?
There's just one more, and it looks like it could be a pretty straightforward one. So I'll go to that, and then perhaps we'll call it a day, because I think that's it for questions. But this one from Marsha: has alternative crop termination methods such as roller crimping been considered? That might be one for Luke.
Yes, we haven't got one, but the neighbour's got one, and it'll fit on our controlled traffic system. So yeah, we're hoping to play around with that over the coming years. We haven't used it, but certainly would like to use it over the next year or two. It's not something that we'll, I don't think, religiously use it through the summer for fallows. If we're doing fallow sprays, which we still have in our system, I don't think it'll quite fit there. But if we're growing a mixed species grazing crop, and we want to terminate that, and it looks like it's going to all line up that we can terminate it with a crimper and not use glyphosate, we will. We're trying to not use as much chemical as we have in the past. I don't know that we will be going organic anytime soon, but yeah, the closer we can get to that without losing productivity or profitability, we'll try and get there.
Our other director, Mick Wettenhall, up at Trangie, built himself a crimp roller, sort of a broadacre model with folding wings, a wide bit of gear. He's had a couple of seasons at it at the moment. There's been a lot of learning happening within SoilCQuest on crimp rollers. I think one of the giveaways is that we're seeing a lot more of them. As Luke says, his neighbour's got one. We're seeing a lot more of them turn up through the district, but they don't get sold through machinery dealerships too much. They're usually, talk to an engineer firm and they'll make one up for you, sort of thing. It's always a great sign when you've got adoption of a particular type of machinery that's not driven from, the commercial side of things outside the farm. So from what we've seen, it definitely has a fit. It's not going to be a tool for every job, but it certainly is going to be a tool that is really useful, particularly for maintaining cover on fallow country. And I think it's certainly a primary focus for SoilCQuest to look at how we can integrate crimp rolling and cover cropping for fallows over the summer. So we'll be looking more deeply into that over the coming seasons. All right, I think that we've gone not too bad really for a SoilCQuest seminar to only go 15 minutes over time. Usually, we rattle on way too long, which in the essence of people probably got to get back to work and so on. We purposely put on at lunchtime so that you could have a sandwich while you're watching the seminar. We've got the next one next Wednesday, and then the Wednesday after. Next Wednesday, we're going to Stewie McDonald's property. Really interesting stuff happening at Stewie's. He's done a lot with cover cropping there, had GRDC trials hosted there, doing a lot with compost and mycorrhizae fungi in particular in amongst his broader system. Really exciting stuff to talk to Stu. Really looking forward to that one. And then there'll be one the following Wednesday on the 20th at near Forbes here. So we'll round it up there now. I started with a welcome to country to the Wiradjuri Nation. I'll finish with, I've actually been learning some Wiradjuri lately. There's a term that I've come to adopt. It's called Dagun Nanana. Dagun means soil, Nanana means to care for. So on that note, I wish you all well. Please shoot us through an email, follow up some questions. We love all any conversations around soil and soil carbon. We're absolutely really dig on that kind of stuff. So please send it through. And thanks everyone for coming. And we'll see you all hopefully next Wednesday. Tell your friends. There's no limit to how many we can have on a Zoom call. So keep sending them around. They'll get better and better as we go. Thanks very much.
Thanks, Webby. Thanks, everybody. Bye.
Yeah.
Bye now.